hello and welcome. In this presentation we will be looking at financial maths and in particular how to calculate compound interest. Now, interest can be subdivided into two categories, that of simple interest and that of compound interest. Now, simple interest is by I suppose the nature of its name, simple. It's simple to calculate, and the thing that you notice is the amount that you borrow, or perhaps the amount you invest, goes up or increases by the same amount each year. The relationship is linear. You could think of that as just being constant addition. In other words, I'm adding the amount of interest I pay year in, year out. Now, with compound interest, the amount of interest that I earn or the amount that I borrow or invest increases in a non-linear fashion. You can see by the nature of this relationship. So, compound is an interesting word. We probably first come across this when we're thinking about chemistry. And it's considered when it's a substance formed when two or more chemical elements are chemically bonded together. Now, from a financial maths perspective, the two elements that we're combining together will be the principal and the interest. Perhaps looking at this visual may help you. Say I borrowed $10,000 and I have an interest rate of 4%. After 1 year, the amount will have risen to $10,400. After the second year, $10,816, and you can see this is increasing in a non-linear fashion. I'm earning more and more interest year after year. Now, I actually put this into a spreadsheet. It's on the next page. I've just copied this across. And what you'll notice, the principal has gone from 10,000 to 10,400, 10,816, and so on and so forth. Now, just put out my pen here. And what you'll notice, when I go from this to this here, I actually am multiplying. I multiply by 1.04. When I move from this year to the next, my principal again, I multiply by 1.04. I could think of this principal as increasing by 4% each year. It's repeated multiplication, and whenever I think of repeated multiplication, I think about index laws. So, the general formula that I use to calculate compound interest, the amount after n years or n compounding periods equals my principal, how much did I borrow, how much did I loan, multiplied by 1 plus the rate. Now the rate is going to be for the compounding period, and it will be represented as a decimal, all raised to the power of n. Probably easiest to go through a few examples, but again, just think about what we're doing. Back to this slide here, we are looking at repeated multiplication. So if I'm going up to here, that's 5 compounding periods. Well, actually 1, 2, 3, 4 compounding periods, and my rate would be 4%. So let's look at a few examples here. Now, I want to calculate the amount payable on a loan of $5,000. The rate is 16.4%, which is quite high, per annum with the interest compounding yearly over 4 years. In other words, I want to know how much do I need to have to pay back to the bank after 4 years if I borrow $5,000 and my interest rate is 16.4% and I have 4 years, so the interest will be there'll be 4 interest calculations. I can just whack those numbers into the formula. You'll notice here I end up with 917872. So nothing all that complex here. It's just identifying your knowns, your unknowns, and putting those into the formula. Where it gets more interesting is this type of example here. Now, say I want to calculate the amount payable on a loan of $5,000 at 16.4% per annum with the interest compounding quarterly, and this time we'll be looking at 5 years worth of interest payments or interest calculations. So again, I need to calculate how much do I need to pay back, and I am borrowing $5,000. Now, what we need to consider is the rate. Now, my compounding period, in other words, my interest is going to be calculated quarterly. So I am not being charged 16.4% per quarter, but rather 4.1%, or as a decimal, 0.041. Now, in other words, I'm dividing the annual rate, the annual because it's per annum, divided by 4 because there are 4 quarterly periods, 4 quarters per year. You may wish to think of this in this sort of representation here. If this distance or this length from there to there is 0.164, that is my interest rate, my per annum interest rate. Now, that can be split up into 0.041 4 times. Now, and the number of times that the interest is going to be calculated, well, it will be 20. Why 20? Well, there will be 4 interest calculations every year, and there are 5 years worth. So simply put that into your calculator and you come with a number there. Nothing all that, I suppose, all that fancy. What you'll notice is I prefer with my calculations to actually put these, like this here, this calculation in my calculator, because what I'm doing is eliminating any possible rounding issues. We'll move on to one final example. So, say I wish to calculate the amount payable on loan of $5,000 again, 16.4% per annum, with the interest compounding monthly over a 6-year period. So, again, reading the question, I need to calculate the amount, the principal, how much I've borrowed, $5,000. Now, the rate is, notice this number's getting a little bit small, 0.0136. Actually, I have rounded this number. It really should be 6666667. So it's effectively 0.164. That's my annual interest rate divided by 12 because the interest is being calculated every month. And the number of payments will be 72. How do I get 72? Again, there will be 12 multiplied by 6. 12 payments per year, and there are 6 years worth of payments. So what you'll notice now is I start to put start not to do these calculations here. Let my calculator do those for me. So put the numbers in my calculator, come up with an answer of 13,286.20. So that is the amount that I will I will have to repay after 6 years when the interest rate is 16.4%. High interest rate, a lot of repayment, so effectively the interest that I have been charged would be, well, 13,286.20 minus the 5,000 which I would have originally borrowed. So in other words, the bank has made a tidy sum of $8,286.20. So that is it for the teaching. For this particular lesson, I'll leave you with one slide which I found under Google Images, which you may or may not find interesting. So until next time, good maths and bye for now.